Okay. This is the last lecture. So we are in and it has been 14 weeks. Conservative of energy. And you guys have done, by right, lecturing should be 36 hours only in a course, but you guys have done more with me. Appreciate the effort and the time and the Fridays. I have not checked regarding the course evaluation, like how many students did the course evaluation. But I got a hint for all of you regarding the final exam. And the hint is very important. And how many of you think that I bullshit? I don't, right? Right? Final exam, you have to know all the examples in the lecture. And you are going to have 3 questions. But more important is this. There'll be a question from homework number 9. Is that enough or not enough? Okay, let me ease your pain. It will be either question number 4, question number 5, question number 6, question number 7. No, that's too much. Or question number 8. Like, it's not as good, right? Okay, it'll be between question 5 to question 8. I repeat again. It'll be between question 5 to question 8. Okay, this is to shorten your time for studying. Okay? Yes. Say it again. Yeah, if all 3 questions come from 5, 6, 7, 8, is it a jackpot? Ching ching. GK store. So I've been going like 20 examples on like forces, like they don't seem to be important. Seriously, it is important. Yes. Okay. So one question will be from question 5 to question 8 in homework number 9. Are we clear? Okay. So that is my hint. Okay. More than welcome. Okay, we're going to continue. Some of you like thank him for what? It's not even any good help. Right. So we found our V2. The next thing, okay, let's very quickly go back to this question. Okay, so this question, we are going to determine the angular velocity at the instance when theta is equal to 90. So what we have done yesterday, we have considered the weight of the pendulum. We have considered the spring unstretch and stretch. So now we are going into the kinetic, and we also have calculated the potential energy at point 2, okay, or stage 2. So next we are going to focus on the kinetic energy. Okay, so for the kinetic energy, we know that T1, position number 1, is equal to 0, and position number 1 when theta is equal to 0 degrees. Then we're going to determine T2. Okay. So to determine T2, I will write in, we have to determine T2 when now theta is equal to 90 degrees. So let me get the diagram. So with the diagram be easier for us. Okay, so this is the diagram that you see. So this will be equal to T2 will be equal to half mvg squared and plus by half ig omega squared. Okay. So from here, note that Vg is also equal to Rg omega squared. Why? Because the pendulum is rotating about a fixed what? Fixed axis. Okay. So you have half. Mass of the pendulum is 30. V subscript G means its center of gravity. Okay, so the Rg omega is 0.35 omega, and the whole thing is a square. Plus by half, we are given the Ig, so we are given the mass, and we are given the K, so this is mk squared. Okay, so 0.3 squared, and we multiply by omega squared. The outcome of this zero 0.35 squared times by 30 times 0.5 plus 5.5 times 30 times 0.3 squared is equal to 3.1875 omega squared. So when we put everything together, so we apply conservation of energy. Basically is T1 plus by V1 is equal to T2 plus by V2. And we know that T1 is equal to 0. V1 is also equal to 0. We calculate them yesterday. T2 is 3.1875 omega squared plus by V2, which we calculate to be minus 49.005. From here, omega will be equal to the square root of 49.005 divided by 3.1875. So it's 3.92 radians per second. It's not really a difficult problem, but most important thing, when you calculate potential energy, kinetic energy, okay, it's all based from where? The center of what? Gravity. Yes. Say it again. You mean this one over here? This one? On the right. Oh, you're right. I don't know why I wrote a square down there. Thank you. Yes. Yes. It has both rotational and linear because you have Ig alpha And you also have V equal to what? Omega R. Okay, for that reason. Okay. So the last 4 questions I told you, and we are doing 2. Does that make sense? If you look at your homework, we have what? If you look at your homework, where's the homework now? I lost the homework. If you look at the homework, right? So what questions did I say will come out? Question 5, 6, 7, or 8, right? So I'm doing 2 already. Okay. So the next question I'm going to do is question number 7. Okay. So for question number 7, okay, so this is the last example. Yes. I just told you, right? Right? So example number 1 for today. Okay, again, this is not really a difficult question, but you just need to like focus and analyze, okay? So what we have down here is the 2 kilogram slender rod are pin connected and released from rest at the position of 90 degrees. So when you read a question like this, okay, rest at the position of 6. Okay, means this is the initial position. If the rest has an, if the spring have an unstretched length of what? 1.5 meter. Determine the angular velocity of the rod BC. So we are going to determine what is omega BC. Okay. When theta is equal to what? When theta is equal to 0 degrees. Neglect the mass of the roller at point C. So we are asked to neglect the mass of the roller. Okay. So we know that we are going to apply conservation of energy. And we know that we are going to apply T1 plus by V1 is equal to T2 plus by V2. Okay. So you have to define 1 being what? Theta is equal to 60 degrees. And the subscript 2 means theta is equal to 0 degrees. So if we look at the structure, right? A to point B is what? Rotation about a fixed axis. Right? So point A or rod AB is fixed at point where? Point A. Now BC is more complicated than that. Okay? Because rod BC is different from rod AB because for rod AB, point A is what? Lock. You don't you don't allow it to have motion in both x and y direction. So for this case, at point A, xa is equal to 0, ya is equal to 0. At point C, if we now focus on member BC, right? For member BC, y at C is equal to 0, but x at C is not equal to what? It's not equal to 0. And this point over here, x at point B is not equal to 0, and y at point B is not equal to 0. So this will be what? this will be having what? This is like a general what? General motion, i.e., it has both a rotation and what? Linear motion for this case. Okay, and none of, sorry, both have rotation, linear motion, but none of them have what? But the member BC is not about a what? Fixed axis. Repeat again, it's not about fixed axis. Okay. So other further information that we know is the unstretched length is equal to 1.5 meters. Okay. And the max unstretched length of the spring is 1.5 meters. Okay. And the maximum stretch length of the spring is 4 meters. Why 4 meters? Let me get this diagram clearer to you so you can see. Right? So if you could visualize when theta is equal to 0, this entire system, right? So this is point A to point B, and then this is